So when I say stability of carbanion, you should know what are all the types of carbanions are there. I think I've already given, but let me rewrite it once again for you. So either you will have all the three of them has hydrogen atom, only one hydrogen atom, or one alkyl group, or all three are gonna be alkyl group. And very important aspect, a minus charge. So this is called as methyl carbanion, primary carbanion, secondary carbanion, and tertiary carbanion. Remember, when you take a carbocation, the positive charge will be better balanced by the negative charge. So if there is a positive charge in the central carbon, if there is an electron releasing group like alkyl group, it will stabilize. But remember, alkyl group is still going to be electron releasing, but carbanion has more electrons, so there is a repulsion. So greater the repulsion, what will happen? Lesser the stability. So look at this particular example. There is no electron releasing group. In this molecule there are 2 electron releasing group. In this molecule there are 3 electron releasing. So more stability in this case, more repulsion. In this molecule the repulsion is more. What about this molecule? Lesser repulsion. Thereby what will happen? This becomes more stable. And this becomes less stable. Therefore you can write the stability like this. So this is how the stability of carbocations are explained. Carbanions are explained. Not only here, you can also see right? Can I move forward? So not only stability plays an important role here, reactivity. When I say reactivity, let us take the molecule CH3, CCH3, CH3, Br. So the bromide ion, what you added, will automatically be more electronegative. The carbon becomes more electropositive. So as a result of that, what will happen? The electron will move from this side to this side. So you will get CH3, CCH3, CH3 plus Br minus. So why the electron is moving towards bromide? The major reason is the carbon becomes more electronegative because of the inductive effect. Because of the inductive effect, the carbon becomes more and more electronegative. Thereby what will happen? The charge will automatically move towards the bromide. So reactivity can be better explained by this. Other than this, you can also talk about acidity. So acidity means a molecule should becomes RO minus and H plus. That is, the hydrogen should be easily liberated. Now you take for instance a molecule like acetic acid. This is an acetic acid molecule with 3 hydrogens. Now what am I going to do? I am going to remove one hydrogen from each of them. In the last molecule I am going to remove all the hydrogens. And then in place of hydrogen I am going to replace chlorine. Remember, chlorine is in minus I group. Minus I group means it will attract the electron towards itself. So it will pull the electron. So now what will happen? The carbon becomes more and more electropositive. So this will become more and more electropositive. So this will be highly electropositive, partially electropositive. So what will happen? The hydrogen can easily go out. So what will happen here? The hydrogen, the proton gets moved automatically. But here it gets liberated with some difficulty. That is why the first molecule what you saw was called as chloroacetic acid. Chloroacetic acid, which is actually the least acidic. Okay, more acidic will be dichloroacetic acid, while the trichloroacetic acid is highly acidic in nature. Make a note, ma. Once you copy, let me know. We'll move forward. I'm going to take same acetic acid molecule. While this time, instead of having all of them as hydrogen, I'm going to have alkyl group attached to it. For example, here 2 hydrogens, here only 1 hydrogen. So the remaining group will be alkyl. For example, let me take methyl. So if all of them are methyl, what will happen is the question. Remember, methyl is an electron releasing group. So if already electron is released, what will happen? The carbon will be more electronegative. So the H plus cannot go by giving the electron because of the repulsion caused by the electrons. So which will be more acidic in this case? So it will be reversed. So this will be more acidic than this. So which is more acidic than all of them if you ask? It will be automatically the acetic acid, which has only hydrogens around them. So if you take this example and keep it a little bit aside, and if you take the other example, which will be more acidic, it is CH3COOH. Remember, here also methyl is an electron releasing. So which will be more acidic among all? HCOOH. So please make a note, formic acid is more acidic than anybody in this group. So lesser the electron releasing group, greater the acidic nature. Copy ma? Write down the next topic. Electromeric effect. Remember, unlike our inductive effect, this happens only in unsaturated compounds. That is, it can happen between C double bond C, or it can happen C triple bond C, or it can happen C double bond O. Another one, it's a temporary effect. It is not a permanent effect. So this is just the interaction between the attacking group and the substrate. Please make a note. So what is electromeric effect? It is the interaction between attacking group and the substrate. For example, you take an alkene and you have something called proton or H plus. Now what will happen? The electron from the pi cloud will attack the H plus. So thereby what will happen? The carbon will have one proton attached to it. Since the double bond is common to both the carbon, there will be a positive charge on this carbon. So here what you see is the the substrate attacks the attacking group. Please make a note. So H plus is a nucleophile. Electrophile. It loves electron. That's why the electron is coming to it. So this is the substrate, and here it is the electrophile. So substrate will attack the electrophile. So the interaction is the attacking of the substrate to the electrophile. Another case where the attacking group will attack the substrate, like you take cyanide ion, which is treated with carbonyl carbon. In carbonyl carbon, this is positive and this is negative. So this will attack from the back side and the electron goes to oxygen. So thereby what will you get? So thereby what will you get? You'll get cyanide attached to the carbon with a double bond, and the O will have minus charge on the top. So here cyanide is the nucleophile. Please make a note. This is the substrate. So the attack will be in this direction. So the first one, where the pi electron is donated, is called as Plessy effect. If the pi electron is rearranged, we call it as minus E effect. Copy ma? So this is called as negative electromeric effect, and that is called as positive electromeric effect. It is called as mesomeric effect or resonance effect. What is the next concept, ma? Mesomeric effect or resonance effect. I think we have already talked about mesomeric effect in our hydrocarbon lesson. So I'll just give you a small introduction. You can just copy from there as well. So mesomeric effect is also called as the resonance effect. Mesomeric effect is also called as the resonance effect. For example, CH2 double bond CH, single bond CH, double bond CH2. What is the name of this molecule? This is buta 1,3 diene. So this molecule will undergo resonance. How does it undergo resonance? When this electron shifts, it will come back here. So it will become CH2, single bond CH, double bond CH, single bond CH2. There is a negative charge on the top because of the extra electron that has come. So you put a minus charge. Since it has lost one electron, this will have a positive charge. Again, what will happen? This will come back here, this will go back and gives rise to that. Not only in this direction, it can also happen in the other direction, like CH2 it can also have CH2 CH, double bond CH, single bond CH2, where the charge can be in the opposite direction, like this can be plus and this can be minus. Again, what will happen? The resonance can go in this direction. So all of them are resonating structures. And we have already seen what are all the various groups. In mesomeric effect, we have plus R or plus M group, minus R or minus M group. These are all called as electron releasing group. These are all called as electron withdrawing group. So please check your notes in hydrocarbons. There I have given you two examples also. So negative mesomeric effect, positive mesomeric effect. You want me to draw the resonance structures once again for plus R and minus R, or you will refer from hydrocarbon?
Draw it again.
Okay. Na romba kovama solren.
Oh, I'm having sore throat.
Oh, okay. Okay, no problem. Yes, ma, we'll see. So let us go with this. Check if the board is visible to you. So this is OH. So the electron comes here and it will occupy the ortho position. You remember this diagram before itself? We saw. So there is a minus charge, double bond O, Since there is a loss of electron, you should put a positive charge on oxygen. Again, this electron enters here. This will occupy the para position. Again, what will happen? The electrons are in the opposite direction. OH is as usual, and the minus charge is here. So you have to put a plus charge here. Again, this enters, and this will occupy the ortho position. Again, what will happen? There is a minus charge here, and then OH. So again, what will happen? There will be a positive. This will go, and this will given back. So this is called as electron releasing or plus or plus M group. It is called as positive resonance effect. Okay, but if you take nitro group, take benzene ring, N double bond O. What is the nature of this molecule? The electron will be taken up by the nitrogen. So it will have double bond N, O minus with the O. And there is a positive charge in the ortho position. Again, this will move here. You get double bond. There is a positive charge here. Again, this will shift here. So finally, you will have so again it will shift here, and this will come over. So this is minus R or minus M. Copy this, ma. Let me repeat. An electron releasing group like OH or NH2 or CH3, Cl, Br, they will increase the electron density in the benzene ring. While minus R or minus M group like nitro, aldehyde, carboxylic acid, ester, they will decrease the electron density from the benzene ring because of the electron pull. While all the other group which belongs to plus R or plus M, they are all electron releasing or plus M group. Is that clear? Make a note of it, ma. So for the next concept is called as hyperconjugation. There are various names given for this hyperconjugation. It is also called as no bond resonance, or it is called as Baker-Nathan effect. So what do you mean by this no bond resonance or hyperconjugation? So let me explain. Again, this will happen between an sp3 carbon attached to an sp2 carbon. For example, it can be a carbocation like this, or it can be between a CH2 double bond CH like this. Remember, both the carbons which are having positive and negative charge, they all have what is the hybridization? They have sp2 hybridization. Similarly, if you take this carbon and if you take this carbon, both of them are sp3. but please wait. I think I have to add one more. So CH3 attached to CH double bond. So it should be like this. So in that case, what will happen? You have to take sp3. So only sp2 carbon or sp3 carbon will happen. So it is very clear that this is for an alkene. I'm sorry, that is for the carbocation, and this is for the alkene. So if you have these two systems, in these two systems you can find very clearly hyperconjugation happening. So what is hyperconjugation? In a very simple language, you can say that it is the delocalization of electrons of a sigma bond. Delocalization of electron of pi bond is resonance. Delocalization of electron of sigma bond is called as hyperconjugation or Baker-Nathan's effect or no bond resonance. And this is a permanent effect. Please make a note. Like your inductive effect, this is also a permanent effect. So for example, let us take an alkene. As given in your textbook, I am taking the same alkene. I am not taking anything else. So let me take the example CH3 single bond CH double bond CH2. So this is called as propene. Now let me expand it and write so that you can understand it better. CH So for my convenience, I'm going to shade the hydrogen. How many hydrogens are there? 1, 2 and 3. So if there are 3 hydrogens, you will get 3 hyperconjugations. For example, if this electron comes, it will occupy here. So you will get H, C, H, double bond CH, single bond CH2 minus, and remember the first H will be in H positive. So again this comes back and this joins. This is one hyperconjugation. What is the other hyperconjugation? Now the second one will give. See, at a time not both of them will give. This is also a mistake. You should not misunderstand that at a time both of them will not give. So if the first hydrogen is given, now I'm using a different color so that you can understand it better. So this time it goes here. This is without the first one. So what will happen in this case? Again, I'll put little bit lower so that you can understand it better. So this time the first hydrogen will be intact. Check carbon. The first hydrogen is there. The bottom hydrogen is here. But the hydrogen which has lost electron is on the back side of the carbon. Double bond CH, single bond CH2 minus. Again what will happen? This electron shifts here and this electron comes back. Now what is the next carbon, next hydrogen, the bottom hydrogen? Again what will happen? This is the third one. Remember, when one hydrogen is giving the electron, the other hydrogen will be intact. You should not write all the hydrogens together. Did you notice that? Rifa, are you noting it or not?
Yes, sir.
So please make a note that you should always be careful while one hydrogen is giving the other hydrogen. So how many hyperconjugations for methyl? So if methyl is attached to an sp2 carbon, so R attached to sp2. So if methyl is attached, you get 3 hyperconjugation. No sir, I have only CH2 attached. Then you will get 2 hyperconjugations. No sir, I have only CH1 hyperconjugation. No sir, I have only C. No hyperconjugation. Right, ma? Is the board visible to you? I've given all of them together. So they have given few other examples like CH2, double bond CH, single bond Cl, where you find lone pairs of electron on chlorine. So CH2 single bond CH, double bond Cl will have a positive charge and there is a negative charge. Again, this can come back. So this is in case of the molecule called vinyl chloride. This is in case of vinyl chloride. And again, you take some other molecules as given in your textbook. For example, you take CH2 group attached to C triple bond N. So in this case, if you check, all of them are either sp3 or sp2 carbon attached. Still the resonance goes on. So look at this example where the electrons goes here and the nitrogen will bear the negative charge. So CH2, single bond CH, double bond C, double bond N minus. Since it has lost one electron, there is a positive charge. Again, this can come back.
Copy, sir.
Then Amma, so based on the hyperconjugation also you can talk about the stability of the carbocation. We told no, inductive effect also plays the carbocation. Likewise, stability of carbocation can also be explained by hyperconjugation. So let me explain it. So as usual, so there are totally how many protons? Here there are 3 protons. Please make a note, ma. Here there are 3 protons. Here there are 2 protons. Here there is only 1 proton. So the remaining are all alkyl groups. So now, instead of writing the alkyl groups, let me write methyl so that you can understand that it's gonna be methyl. Now you can understand how many hyperconjugation it can contribute. So I already told 1 methyl can contribute how many hyperconjugations? Just go back to your notes and check. 1 methyl can contribute how many hyperconjugations? If I am asking you a question, it would be better if you can respond so that we can easily finish. Hello?
Yes, sir.
How many hyperconjugations per methyl? Just now I gave the notes.
103. No.
You are not copying everything. That is why. That is why you are stammering. Then why? What is the problem? I gave you the notes. No. 1 methyl can give how many hyperconjugation? CH2 can give how many hyperconjugation? CH how many all those things I wrote. That's why I'm asking. 1 now. The number of hydrogens will be equal to the number of hyperconjugation. So methyl has 3 hydrogens. So how many hyperconjugation?
3.
So 3 hyperconjugation. Okay. What about this one? How many methyl are there? 2 methyl. So 6 hyperconjugations. What about the last one? How many methyl are there? 6. 3 hyperconjugation. That means 9 hyperconjugations are possible. 3 methyl will contribute 9 hyperconjugation altogether. Each of them will give 3. So please make a note. Greater the number of hyperconjugations, greater the stability. Greater the number of hyperconjugation, greater the stability. So there is no hyperconjugation in this case. Which one? Because there is no electron releasing group. So who's more stable? So you can talk about the stability of carbocation using hyperconjugation as well. Finished, Amma? Shall we move forward? So types of organic reactions means substitution reaction, addition reaction, elimination reaction, oxidation and reduction reaction, rearrangement, combination. Other than this, we have polymerization, functional group, intergroup conversions. One functional group can be converted to other. So like that, we have many such examples also. Have you copied? Can I go to substitution reaction?
Yes, sir.
Now in substitution itself, you have 3 types. Write down. So in substitution reaction itself, you have 3 types. What are the 3 types? Nucleophilic substitution reaction, electrophilic substitution reaction, free radical substitution reaction. I'll give you one example. You please make a note. So CH3Br plus OH minus. Remember, OH minus is the nucleophile. So it will attack from the behind and the bromine will be going out. So you'll get CH3 OH plus Br minus. This is nucleophilic substitution because nucleophile is attacking. Electrophilic substitution means we have already studied. You remember benzene ring. Plus you treat it with nitro group, nitronium ion. You have nitronium ion, NO2 plus. What will happen? The hydrogen, the electron from the benzene ring will attack. You remember? So one hydrogen will be there. Another one is NO2. So in case of benzene, you will treat it with NO2 plus. Remember, there is already one hydrogen attached. So this electron will come and attack the nitronium ion. So you'll get hydrogen here and then nitronium ion. At the end again what will happen? Deprotonation takes place. So you will have so plus NO2 plus. So this will attack. So therefore you will get so minus H plus will be liberated. Therefore you will get nitrobenzene. Remember, what is this called? This is your electrophile. So this is electrophilic substitution. Similarly, I told you CH3Br. So in presence of OH minus, I told you come and attack from behind. So Br minus will go out. So you'll get CH3 OH. So what is the role of OH here? The role of OH here is nucleophile. Hence it's called as nucleophilic attack. You can also have free radical mechanism. In your textbook they have given free radical mechanism also. For example, you take CH 3 single bond H plus Cl2 single bond Cl2. So what will happen? Let me rub and rewrite 1 second. Plus you will get Cl single bond Cl. So this happens only in presence of light. So what will happen? The electron gets added up here. So you'll get minus HCl getting removed. So finally you'll get CH3 dot plus Cl dot, free radical. Now they both will join and form CH3 single bond Cl. So this is free radical mechanism. So free radical substitution, electrophilic substitution, nucleophilic substitution. Shall we move forward? Now let us go for addition reaction. So addition reaction, you always have three types of addition, namely nucleophilic addition, electrophilic addition, free radical addition. So let's see the examples. So this addition reaction normally occurs between unsaturated compounds. So let me give you an example of electrophilic addition. So you take C double bond C, an alkene, and then treat it with Br2 single bond Br. So electrophilic means it will love electrons. So automatically what will happen? First the Br will be removed. So minus Br minus. And then what will happen? The intermediate will be formed. Later, another Br minus, the Br minus liberated, right? That will come and attack on this side, and thereby the electrons are given. So your final product will be dibromo compound. So this is an example of electrophilic addition. Similarly, you can also have something called nucleophilic addition reaction. So when I say nucleophilic, the only thing that comes in our mind is the carbonyl compounds. Just treat it with HCN. So in the first step, the electron from the cyanide will attack the carbon and oxygen will have minus charge. So minus H plus is liberated. So thereby you get a cyanide attached to the carbon here. And there is a minus charge. The proton that got removed will get added up here in the next step. And thereby you get something called cyanohydrin. The molecule is called please make a note, cyanohydrin. So that is about the addition reaction. The next one would be free radical addition. Again you have CH2 double bond CH2 plus HBr. So this electron goes here and this electron gets added up. So what will happen? The CH2 becomes CH3 and the bromine gets added up here. So this is a free radical mechanism. This happens in presence of light and organic peroxide. So the next reaction is called as elimination reaction. So elimination is the opposite of addition, where the alkene will become a saturated to unsaturated to saturated. In elimination, saturated compound becomes unsaturated. For example, CH3, CH2, CH2, Br. So just treat it with alcoholic KOH, and very important, you have to heat it strongly. When you heat it strongly, what will happen? The beta proton will give its electron. So the beta proton will give its electron, thereby bromine goes out. So you'll have Br minus, you'll have HBr. And look at the product form. CH3 is as such, there is a CH, double bond CH2. So this is 1 bromopropane, which has become propene. So you can see a saturated compound without any double or triple bond has got converted to unsaturated compound called alkene. Am I making sense?
Yes, sir.
So let me go to the next reaction. Write down oxidation reaction. Oxidation means addition of oxygen, reduction means addition of hydrogen. So for example, you take CH3, C double bond OH. This is called as acetaldehyde. We just treat it with potassium permanganate in presence of H plus, or you can use K2Cr2O7 in presence of H plus. What will happen? Nothing will happen to CH3, while your CHO becomes C double bond OH, which is nothing but your ethanoic acid, right? Similarly, we can also look for reductions. What do you mean by reduction? Reduction means addition of hydrogen. For example, you take benzene ring. When you take benzene ring, where there is only one hydrogen in each of the carbon attached, you just simply treat it with platinum in presence of hydrogen. You will find cyclohexane is formed. So benzene becomes cyclohexane. Another oxidation reaction also you can see. Let me just pull it down. This is also an oxidation reaction which is given in your textbook, okay? So they have taken this is 4-hydroxy phenol. Just treat it with K2Cr2O7 in presence of H+. See what is going to happen. This is called as para-benzoquinone. So these are all oxidation reactions. Check ma. Elimination and oxidation are given together. Copy. So functional group interconversion. So how do you convert one functional group to other? So the functional group interconversion is a very important what I can say, very important topic to be learned, because this is what going to come for the next 2 years. For example, you take alcohols. Alcohols are of 3 types. In your textbook they have given only 2, so I'm just stopping with that. So RCH2OH, RCR-HOH. There are only 2 options given in your book. So when you do the oxidation of this using K2Cr2O7 in presence of H+, K2Cr2O7 in presence of H+, you get RCHO, RCR- double bond. And if you further oxidize also using K2Cr2O7 in presence of H+, you'll get RCOOH. Here the CC bond will break, so you'll get RCOOH plus CO2 plus H2. This is primary alcohol. This is secondary alcohol. This is aldehyde. This is ketone. Here also you get a carboxylic acid. Here also you get a carboxylic acid. Please copy. Remember, they can also be reduced back. For example, you take this compound here. So when it is reduced back with lithium aluminium hydride, you get the corresponding aldehyde and ketone. So which is not possible in case of your carboxylic acid because the bond has broken, but it is possible here. Please copy this, ma. So that LiAlH4 is called as lithium aluminum hydride, which is a reducing agent. K2Cr2O7 in presence of H plus is called as dichromate, potassium dichromate, which is an oxidizing agent. So oxidizing agent adds the oxygen, reducing agent adds the hydrogen. So that is what you see in the functional group interconversion of primary alcohol to aldehyde carboxylic acid, or secondary alcohol to ketone and carboxylic acid at a CC bond cleavage. What will happen to alkyl cyanides? So take RC triple bond N. So lithium aluminum hydride. So RC will be there. The C becomes CH2 and N becomes NH2. Okay, so this is one methodology. No sir, you can also take another compound called RC double bond O NH2, which can also give you the same product when you reduce it with lithium aluminum hydride. Remember, you can also further add H3O plus to this, so you become R will be there, C double bond O becomes OH. You can directly get this also when you treat H3O plus. You can get directly amide also when you are going to hydrolyze with base. So I'll write the name of the compound so that you can check. This is alkyl cyanide, primary amine, amide, carboxylic acid. So we call this as complete hydrolysis. This is called as partial hydrolysis. Copy this, ma. Now look at the last reaction, very important. They have given in words, but I'll write it in equations so that you can refer in the future. So R CH2 CH2Cl. So to this I'm going to treat it with two ways I can treat. Number one, alcoholic KOH in heat. Another one, aqueous KOH. RCH2 single bond. So this will undergo beta elimination. This molecule will undergo beta elimination. So what will happen? RCH double bond CH2. In this case, what will happen? RCH2 CH2 will be there. In place of Cl, you will have OH. So you will have H2SO4 you'll have to remove this, you have to add concentrated sulfuric acid and heat it to 443 Kelvin. So what all you have got, write down the names. This is alkyl halide, this is alkene, this is alcohol, and this process is called as dehydration. Copy ma.